Well, student, today is the next topic. It is about the electric flux. It is about the what? Electric flux. First of all, flux means what? First things it is about the flux means what? About the flux that we have studied in 11th science in a chapter fluid mechanics. In that chapter we have studied about there is a one small pipe. Through this pipe, in 1 second, how much liquid comes out through this cross section. Mass of the liquid comes out through this cross section in 1 second. It is called the mass flux. Mass of the liquid comes out through any cross section in 1 second. It is called the word mass flux. Another thing is, volume of the liquid comes out through any cross section in 1 second. It is called the volume flux. Once again, volume of the liquid comes out through any cross section in 1 second. It is called the volume flux. Another example, suppose we open the window. Then what happens? Air will be entered into the window. That is known as an air flux. It is known as what? Air flux. Now today our topic name it is called the electric flux. Today our topic name is what? Electric flux. Electric flux means what? There is a one cross section or any planar body. Through that cross section the electric field lines are passing through, or the electric field lines are linked with the plane. That is called the what? Electric flux. Electric field lines are linked with the plane. It is called the what? Electric flux. Okay. So now there are some diagram. It is to be drawn on this board about the electric flux. So now first of all, this is our uniform electric field lines. So this theory is divided into two parts. The first theory that is represent the flux in a uniform electric field. And the second part, it is to be related to the flux linked with the non-uniform electric field. The first part it is about the uniform electric field. The second part it is about the non-uniform electric field. So right now these all the electric field lines are uniform. In this uniform electric field, normally you pass over one plane. Then what happens? These all the field lines are linked with the plane. These all the field lines are passing through this plane. When the field lines are passing through the plane, that means what? There is a electric flux. There is a what? Electric flux. If the electric field lines are passing through the plane, that is called the what? Electric flux. But magnetic field lines passing through the plane, that is called the magnetic flux. Magnetic field lines passing through the plane, that is called what? Magnetic flux. But right now, the electric field lines are linked with the plane. Electric field lines are passing through the plane, that is called the electric flux. Okay. Now some diagram. First diagram it is completed. Now into the second diagram. What happened? A plane is parallel to the field. In this diagram, plane is normal to the field. Then what happened? The field lines are not passing to the plane. When the plane is parallel to the field lines are not passing to the plane. You can see that. In this diagram, the field lines are parallel to the plane. The flux is zero. The field lines are parallel to the plane. The flux is what? Zero. Student, observe this diagram and this diagram. In this diagram, the plane is exactly normal to the field. Or in this diagram, slightly the plane is going to shifted, or it is slightly tilted by angle of theta. A plane is slightly tilted by angle of theta. Then what happened? The number of field lines now passing through this plane goes toward decreases. Then flux is also goes to decreases. If more number of the field lines are linked with the plane, a flux is more. If the less number of the field lines are linked with the plane, a flux is what? Less. The flux means what? Number of field lines passing through the plane, it is called flux. More number of field lines passing through the plane, flux is more. A less number of field lines are passing through the plane, a flux is less. The flux is nothing else, students. It is just a mathematical concept that gives the number of field lines are linked with the plane. A flux is nothing else, students. It gives the number of field lines are linked with the plane. It gives the number of field lines by using the word flux. We can calculate the number of field lines by using the word flux. Okay. Now there is a more deeply and description about the flux that is to be shown on this board. First thing is about the number of field lines crossing a unit area plates normal to the field. Number of field lines crossing a unit area plates normal to the field at a point is measure the strength or intensity of the electric field at that point. So in this statement, it is simply gives the word electric field intensity. It is directly proportional to the number of field lines linked per unit area. Electric field intensity, it is directly proportional to the number of field lines are linked per unit area. Or also we can say that the number of field lines are passing through per unit area normal to the surface is directly proportional to the electric field intensity. If the more number of field lines passing through the surface, more electric field intensity. A less number of field lines passing through the surface, there is a less electric field intensity. Clear? Student, in this equation, suppose we make a subject of n, then number of field lines is equal to, we can write down, it is a E into delta S. Like n proportional, it is E into delta S. Through this equation, we can give the next statement. There is a, if we place a small element of area delta S, if we place a small element of area delta S, so this is our total planar body. This is our total plane, whose total surface area it is S. But in this total surface area, suppose we consider a small element. Name of this element denoted by delta S. This element denoted by delta S. So delta S, it is called the area vector. Delta S, it is called the what? Area vector. Direction of the area vector, it is always normal to the plane. Direction of the area vector, it is always normal to the plane. Suppose this is my plane, or this is my palm. To find out the direction of the area vector, arrange a one pointer or indicator normal to the plane. So this indicator represents our area vector, which is always normal to the plane. Suppose slightly we change the position of the plane, then area vector always remain normal to the plane. Suppose the plane is slightly tilted like this, then area vector always remains normal to the plane. Like right now, this area vector, to find out the area vector of this plane, you are in the pointer. So this pointer is represent our delta S. This plane it is like this. So now normal area vector is normal to the plane, it is in this direction. Like whenever we require to find out the area vector, so please arrange the pointer normal to that plane. That gives the direction of area vector. That gives the direction of area vector. Fine? Okay. Next one, if we place a small element of area delta S normal to the field E at that point, number of field lines crossing it is proportional to E delta S. So this is our area vector, small element of area vector delta S. Number of field lines crossing to it is directly proportional to E into delta S. Directly proportional to the E into delta S. So that we can write down that is directly proportional to E into delta S. So into this diagram, vector E, delta S, both are in a which direction? Same direction. They are in a same direction. But yeah, student, into the second diagram, into this one, slightly the plane is what? Tilt. Slightly the plane is what? Tilt. Then what happened? Area vector, this is delta S. This is the direction of the word electric field E. This delta S makes an angle theta with the word E. Now you select the projection of area vector. The projection of area vector denoted by delta S cos theta. The projection of delta S on the vector E, it is delta S cos theta. Now number of field lines crossing this plane, it is directly proportional to the E into delta S cos theta. In this diagram, number of field lines passing through this plane, it is directly proportional to E into delta S. In this diagram, n is proportional to E into delta S cos theta. That is to be explained into the next statement. Suppose we tilt a area element by an angle theta. Suppose we tilt a area element by angle theta. The projection of delta S normal to E is delta S cos theta. The projection of delta S normal to the E, it is delta S cos theta. This is our delta S cos theta. Again, it is same statement. Now the number of field lines crossing it is proportional to the E delta S cos theta. Is proportional to the E delta S cos theta. So there are two equations completed. When the plane is exactly normal to the field, E delta S. When the plane makes an angle theta with the E, that time E into delta S cos theta. So dear student, the next equation, the field lines parallel to the delta S will not cross it at all. Field lines are parallel to the delta S will not cross it at all. That is to be shown into this diagram. The field lines is parallel to the delta S. No one field lines are passing to this plane, so that the flux is zero. So the flux is zero. In this case, flux is zero. In this case or in this case, the flux is maximum, but in this case, slightly the flux is less. Okay, the electric flux passing through an area element delta S is defined as, that is delta phi is equal to vector E dot delta S. Vector E dot vector delta S is equal to their expansion. It is a E delta S cos theta. So it is a dot product between the two physical quantity. So that by removing the dot, we can write down the word cos theta. It is a E delta S cos theta. So in this equation, it is applicable when the field lines are uniform. This equation is applicable when the field lines are uniform. So that delta phi is equal to, we can say that it is a E delta S cos theta. Okay? So now the next statement, which is proportional to the number of field lines cutting area element. Which is proportional to the number of field lines cutting area element. Cutting is what? They are passing to the area element. Cutting is what? They are passing to the what? Area element. More number of field lines passing to the area element. Flux is more. Again, same statement. A less number of field lines passing to the area element, the flux is what? Less. Okay? Where the theta is the angle between vector E and delta S. Theta is the angle between vector E and vector delta S. Now student, unit of flux. Student, what is unit of E? Newton per coulomb. Studied already. What is unit of area? Meter square. So the unit is Newton meter square by coulomb. Another unit of the flux is, it is a volt into meter. So there are two units, Newton meter square by coulomb, or second unit is volt into meter. So in the equation of the flux, which trigonometric function is appear cos theta. Now the types of the flux, it is total 3. Flux may be positive, negative or zero. Total types of the flux are 3. The flux can be negative, positive or zero. Now when flux is positive, when flux is negative, when flux is zero. When the angle theta it is less than 90 degree, flux is positive. Flux is positive. When angle theta less than 90, greater than 90 degree, flux is negative. When theta less than 90, flux positive. When theta greater than 90, flux is negative. Theta is equal to 90 degree. Theta is equal to 90 degree. Flux phi is 0. Theta is 90 degree. Flux phi is 0. That time what happened? The field lines are not crossing to the plane. The field lines are parallel to the plane. Therefore, the flux is 0. Okay? So now the theory, it is about the electric flux in a uniform electric field. It is completed. It is a one part of the theory. Now there is the same concept about the electric flux. Now you derive the equation of flux in a non-uniform electric field. In a non-uniform electric field. So now this is the diagram in which you can see that these all the field lines are non-uniform. And student, we know very well a non-uniform electric field can be produced by using the point charge. Can be produced by using the what? Point charge. So now the next part about this theory. In the case of the non-uniform electric field, we consider a closed surface lying inside the field, that is as shown in figure. Consider a small surface, closed surface. It is lying inside the electric field, that is to be shown into this diagram. So this is our closed surface. You can see that. Now student, here field lines are non-uniform. Shape of the surface, it is a arbitrary shape, not a regular shape. Then how to calculate this electric flux? Now to calculate this electric flux are linked with this arbitrary surface, arbitrary closed surface, or into this non-uniform electric field. The whole surface, it is to be divided into a very small area element. The whole surface is to be divided into a very small area element. Find out the flux linked with the each area element. Find out the flux linked with the each area element. Then make an addition of the flux linked with the each element, and that addition will be converted into the what integration. Find out the flux linked with the what each area element and make the addition, and that addition will be converted into the what integration. Through this way we can calculate the flux linked with the non-uniform electric field with any closed surface. Okay, so student, now the next explanation. We can divide the whole surface S into a small area element like delta S1, delta S2 up to the delta Sn. Let the corresponding electric field at these elements be a vector E1, vector E2 up to the vector En. Then the electric flux through the surface S will be, total flux will be, that is phi is equal to, it is a vector E1 dot delta S1, flux linked with the first element, plus vector E2 plus dot delta S2, flux linked with the second element, up to the it is a vector En dot delta Sn, flux linked with the nth element. Now make an addition of this flux of the each element. So now this is to be shown by like this: sigma I is equal to 1 to n vector Ei dot delta Sn, vector Ei dot delta Sn. Now student, next step. When the number of area elements becomes infinitely large, n tends to infinity. The number of the area elements is what tends to infinity. There is a large number of area element, and delta S tends to 0. The size of the each element it tends to 0, like it is nearer to 0 but not 0. Size of the each element it is what tends to 0. Tends to 0 means what? That value is nearer to 0 but not 0. The above sum approaches to the surface integral taken over a closed surface. This above sum, it is converted into the what surface integration. In simple language, it is to be shown by like this. But according to our textbook language, the sum approaches to the surface integral taken over our closed surface. Let this sum convert into integration. So, dear student, the next step can be written down like this. This equation, rewrite it. In this equation, now we write down flux phi is equal to limit n tends to infinity, delta S tends to 0. Sigma I is equal to 1 to n vector Ei dot delta Sn. Now student, next things, this summation convert into surface integral. Now remove this sign. Now we are going to integration, and it is called surface integral. Remove this limit sign. Then this delta will be converted into what d. So there we write down vector E dot vector ds. So dear student, this is the equation of the flux. Can be used when the field lines are non-uniform. It is to be used when the closed surface it is an arbitrary set. There is no fixed set. Okay. So that the last statement about this one can be given by like this. Thus the electric flux through any closed surface or open surface. Electric flux through any closed surface or the open surface is equal to surface integral of electric field E taken over the surface. The total electric flux is equal to surface integral of electric field taken over the closed surface. So that this is our statement of the flux. So student, there are two equations of the electric flux. The first equation of the electric flux in a uniform electric field can be used E delta S cos theta. Phi is equal to E delta S cos theta, or simple you can say that it is an ES cos theta. What is unit of the flux? It is a Newton meter square by coulomb, or it is a volt-Newton meter. Total types of the flux are 3, maybe positive, maybe negative, maybe 0. When angle theta it is less than 90 degree, flux positive. When angle theta is greater than 90 degree, the flux is negative. When angle theta is what 90 degree, the flux is what 0. And another equation of the flux, when the field lines are non-uniform, so that time we can use this equation. It is the phi is equal to integration vector E dot vector ds. And simple thing, flux means what? Whenever the field lines are crossing to the plane, then there is a flux. But field lines are parallel to the plane, flux is zero. So that the concept about the electric flux, it is completed. Remember this theory, because the same theory will be coming into the chapter number 4. It is about the magnetic flux. Same equation, only the small change will be takes place. The electric field is replaced by magnetic field. Okay?